All right, thanks for tuning in to check this out mathematics. And I encourage you to like this video and subscribe to the channel and give some comments and watch more of the videos available from Check This Out Mathematics. And in this series, we are looking at formulas that generate Pythagorean triples, and we're looking at the underlying concepts of these formulas. And so these were the three formulas that were introduced in previous videos. And right now we're looking at this first formula that generates Pythagorean triples. And the idea is that we have this value m, which is an element of the natural numbers, the counting numbers. And if you plug any of the counting numbers into these expressions, you'll get an ABC, a Pythagorean triple, where a squared plus b squared equals c squared, and c is 1 more than b. Touch that up there. Okay. Where c is 1 more than the b value. Okay? And we talked about some of the structures behind this formula that generates Pythagorean triples in part A of the video. And now this is part B. And we're going to actually show that these three expressions are a solution to the Pythagorean theorem by running these three expressions through the Pythagorean theorem and showing that it's true that a squared, a is going to be 2m plus 1, so a squared plus b squared, b is going to be the 2m plus 2m squared, and then that will equal c squared, where c is the 2m plus 2m squared plus 1. Okay? All right, so let's do that. And so the one of the things we want to review before proving that statement is this idea that we use in algebra, that x plus y squared is equal to x squared plus 2xy plus y squared. Okay, and so let's first run through this so that that will be helpful in showing this this one here to be true. Okay. Now then, so when we have x plus y squared, that means that we're going to write that down twice and multiply. So x plus y squared means x plus y multiplied by x plus y again. And then we're going to distribute in this fashion. We're going to take the x value and distribute it through the second parentheses. So we'll have x times x and x times y. And then we're going to take the y value and distribute it through the second parentheses. So we'll have y times x and y times y there. Okay, so let's write that out. This gives us x times x, which is x squared. And then x times x is x squared, and now we're going to say x times y. That will give us xy. And so we have distributed the x through the x plus y. And now we're coming back and distributing the y through. So here we have y times x, which is the same as x times y. And so we're going to write that down. Okay, so y times x is xy, and y times y is y squared. Okay, and so now then we have one last thing to do here. We have an xy and another xy. So we have two xy's. Okay. And so then this gives us x squared plus 2xy plus y squared. Okay, so now we can see that x plus y squared does in fact give us x squared plus 2xy plus y squared here. All right, and so now we're going to use this concept to show that this is true, that when we have 2m plus 1 squared, that's the expression for a, and we add that to 2m plus 2m squared squared, that's the expression for b, that we will get 2m plus 2m squared plus 1 squared. That's the expression for c there. And so let's take this first part, 2m plus 1 squared, and apply this formula to expand it. Okay. All right, so we have 2m plus 1 squared. Okay, so now remembering our formula there, that when we have an x plus y squared, we'll get x squared plus 2xy plus y squared. And so the x is the 2m, and the y is the 1. And so we're just going to replace x with 2m and replace y with 1 in our formula up here. Okay. All right, so check this out. We'll say that this is 2m squared plus 2 times 2m, and I'm running out of room here, so we have to write smaller here. Okay, let's see. So, well, let's do it this way. 2m plus 1 squared. It's going to be equal to 2m squared plus 2 times 2m times 1 plus 1 squared. Okay, so you can now see the structure that here, this is 2m was our x, so x plus y squared, the y is 1, and so that's going to give us x squared plus 2xy plus y squared, just like we said here. So you can see how it matches up. And now let's complete the expansion. So this is 2m squared. That means 2m times 2m. And that's going to give us 4m squared. Okay. And then this 2 times 2m, that will give us 4m, times 1 will still be 4m. So plus 4m plus 4m. And then 1 squared, 1 times 1, still 1. Okay, So we have expanded the first part of our uh, Pythagorean generating formula, that 2m plus 1. And so 2m plus 1 squared gives us this expression here, 4m squared plus 4m plus 1. So that's the a squared. Okay, so now we're going to look at the b expression, 2m plus 2m squared, and expand that. All right, so here we go. Check this out. We have 2m plus 2m squared squared. So this is the b squared. So this is our expression for b. And so we had a squared. And now we have the b squared part. And so let's expand this. Again, using this formula here. And so the x is the 2m. And so we're going to say x squared. So that's 2m squared. And then plus the 2xy. So that's 2. And the x is 2m. And the y is 2m squared. Okay, so we have the x squared plus 2xy, just like in our slide here. X squared plus 2xy, and then plus the y squared. So the y is the 2m squared, and so that's plus 2m squared squared. Okay, so we have the x squared plus 2xy plus y squared. 2m is squared is the y, and then we squared. Okay, so let's keep expanding that. So 2m squared, that's 2m times 2m, that's 4m squared. And then let's look at this here. We have 2 times 2 times 2, so 2 times 2 is 4, times 2 is 8, and so we'll have 8 there. And then m times m squared, well that's an m and 2 more m's, so that's m to the third. Okay. And then here we have 2m squared squared. So that's going to be, we'll put that down here just to look at it, 2m squared times 2m squared. Okay. And so here we go. The 2m squared squared means 2m squared times 2m squared. So that's 2 times 2 is 4. And m squared times m squared is m to the fourth. So we'll have plus 4m to the fourth. Okay, so that's the expansion of the 2m squared plus 2m, 2m plus 2m squared squared. That's our b expression. Okay, so let's put that together now. Okay, check this out. So what we did is we had this part here, the 2m plus 1 squared. And so that was 2m plus 1 squared. And then we had the b expression. That's 2m plus 2m squared squared. That's the b. Okay, so plus b squared, that's the 2m plus 2m squared squared. So that's the a squared plus the b squared. And now when we did the 2m plus 1 squared, we got this expression here, 4m squared plus 4m plus 1. So let's write that down. Equals 4m squared plus 4m plus 1. And then, let's see, I'm going to have room. I think I better. Write a little bit smaller here. Okay, so that's 4m squared plus 4m plus 1 plus 4m squared plus 8m to the third plus 4m to the fourth. Okay, so the 2m plus 1 squared, that gave us the 4m squared plus 4m plus 1. So that's what we have here, 4m squared plus 4m plus 1. And now the 2m plus 2m squared squared gave us the 4m squared plus 8m to the third plus 4m to the fourth. And so that's what we have here, 4m squared plus 8m to the third plus 4m to the fourth. And so now we have some like terms. This 4m squared, that's in terms of m squared. And here's another 4m squared. And then we also notice that we can put these terms in order from the highest exponent on down to the m here, and then just the constant 1. So let's rewrite that. Let's put an equals there. Okay, so let's write the highest exponent first, 4m to the fourth. And then next will come 8m to the third. And then next will come m squared. So we have a 4m squared and 4m squared again. So that's 8m squared. 8m squared. Okay, let's see. So now we're down to just m to the fourth, m to the third, m to the second, and m. And there's only one of those, the m term. So plus 4m plus 1. And so what we essentially did is we combined these two like terms. And that gave us 8m to the second. And then we kept this one, and this one, and this one, and this one here. So it's all there. Okay, so that's what a squared plus b squared gives us, this expression. Okay, and so now what we want to show is that when we take the c part of this, that's 2m plus 2m squared plus 1, and we square it, that's the c squared part, that we'll get this same expression for a squared plus b squared. So that a squared plus b squared will be equal to c squared. All right, so let's do that next here. Okay, so check this out here. We are going to take our c expression. So that's c squared. And that's the 2m plus 2m squared plus 1 squared. Okay, and now in order to square this out, we're going to use this same idea here. Excuse me. Okay, so we have we're going to use the same idea here that x plus y squared equals x squared plus 2xy plus y squared. But you notice here that there's two terms, the x and the y, and we have three terms here. So we're still going to apply it. It's just that we're going to group it in this way, that we're going to say that this is x and this is y. Okay? So we're going to say the 2m plus 2m squared is that's going to be x. So x plus y. And so the y is going to be 1 there. Okay? And so we're going to still apply that to this expansion. Okay. So then, all right, check this out. We're the 2m plus 2m squared is going to be our x, and so we're going to write that now as x squared, and so that's going to be 2m plus 2m squared. Okay, so there we have x squared, and now we're going to have the 2xy, so plus 2, and then again the x is 2m plus 2m squared, and the y is 1, and then see if we can fit this all on the same line here. Okay, so that's going to be 1. Okay, so we have x squared plus 2xy plus y squared. That's the 1 there. So we have 1 squared. Let's go ahead and put that in parentheses for consistency here. Okay, there we go. So x is this first bracket. X plus y squared is going to give us x squared plus 2xy plus y squared. Okay, now we have this, oh wait, got my square there. Okay, so this is 2m plus 2m squared. Let's fix that up. Okay, so plus 2m squared. Okay, there we go. So that's our x, and so we have x squared. And now we already did this. We did the 2m plus 2m squared squared when we previous slide, where was it? Oh yeah, here we go. See? So 2m plus 2m squared squared gave us this right here. So we're going to use that again. So that's going to be 4m squared plus 8m to the third plus 4m to the fourth. Okay, so 2m plus 2m squared squared. So we have right here, it's going to give us that same expression that we had before. Okay, so now when we multiply by 1, it doesn't change anything, so we can ignore that. We're just going to distribute this 2 through the parentheses. So that means we have 2 times 2m and 2 times 2m squared. Okay, So 2 times 2m, that's going to be 4m, plus 4m. And then 2 times 2m squared, that's going to be 2 times 2 is 4. And then we'll have m squared, 4m squared. And then finally we have the 1 squared, that's going to give us 1. Okay, so this is the first part of our expansion here. And so now let's look for some like terms. Let's see, and let's put the terms in order. So here's this 4m to the 4th. That would be the highest exponent. We put that first. 4m to the 4th. And then looking through here, we have an m to the 3rd. This is looking familiar, doesn't it? 8m to the 3rd. Okay. And then let's see. Oh, we have a 4m squared, another 4m squared, so that's 8m squared. Okay. And then let's see. Oh, here's the next exponent here, 4m. So we had m squared, and now we just go down to m. And then plus 1. Okay, so when we expand 2m squared plus 2m plus 2m squared plus 1 squared, this is the expression that we get. And having a deja vu. Are you having a deja vu? Because I think that's what we got here. Let's check it out. Okay, so there we go. Get me in the middle there. All right, there we go. Okay, so on this slide here, 2m plus 1 squared plus 2m squared, that's our a squared plus our b squared. And that gave us 4m to the 4th plus 8m to the 2nd, 8m to the 3rd plus 8m to the 2nd plus 4m plus 1. Hey, that's happening there. And now our c squared, that gave, hey, those things matched, don't they? Yeah. Okay, so what we say is true. That if we take these expressions and we plug it into the Pythagorean theorem in this fashion, then we do, in fact, get a squared plus b squared equals to c squared. Okay, so that's it. That's how that this formula that generates Pythagorean triples works, because it does work. It does fit into the Pythagorean theorem. Okay, so as long as we can pick any m value and run it through these expressions, and we will get an a, a b, and a c that gives us a squared plus b squared, and the c value will always be 1 more than the b, and it's going to work every time. So that's pretty cool. We have a Pythagorean theorem, and then we have formulas that generate triples for the Pythagorean theorem. Who knew that? All right. Okay, so that's it for this Check This Out Mathematics. And so I encourage you to like and comment and subscribe and watch more of the videos. And in the next series of videos, we're going to look at this second uh, formula that generates Pythagorean triples. That's this one here. Okay, so tune in for that when it's posted. All right, thank you very much. This is Mr. O'Donnell signing off for Check This Out Mathematics. Thanks for tuning in.